Hello out there, and welcome to our lesson on solving by factoring. So in the last few sections we looked at different processes for factoring. So we always start by looking at or factoring out the GCF if that's possible. And then if we have trinomials, we looked at a process called bottoms up for factoring. We saw if we had four terms, and actually this is in the first section, that we would factor by grouping, which is basically taking GCFs. And then we said if we have two terms, and those two terms were a difference of squares or a sum or difference of cubes, that we could factor using conjugates, or we had a set of formulas for our cubes, right? So factoring for the sake of factoring is not really helpful, but the factoring is there in place so that we can actually use it for other purposes, right? We don't want to factor just for factoring. The factoring helps us do other things. In this case, it's going to be helping us solve new types of equations. Now, I don't know if these are really new for you, but let me just make myself clear here. If we were solving this linear equation, when we solve a linear equation, the goal is to get x all by itself. So I subtract 1 from both sides, which would leave me 2x equal to 4. I divide both sides by 2, and now x is all by itself equal to 2, and there's my one solution. And the reason we get one solution, again, is because this equation is linear. This degree of 1 makes it linear. That degree of 1 also tells me I'm looking for one possible solution. Okay? A quadratic equation has a degree of 2, which means we're going to be looking for two possible solutions. So the question is, can we find them the same way? And when I say the same way, I mean, can we find them by getting x by itself like we did in the linear equation? Well, if I started by, let's say, subtracting 3 here, then I'm left with x squared plus 4x equal to negative 3. Where would I go from here? Well, I can't solve for 1x when I have two terms that have x's. Now, if this was an x and a 4x, those two terms are not an issue because they could be combined to make 5x. But I can't combine these two terms, which means I can't do anything else here to try to get x by itself. So what we want to do is take a different approach with the quadratic equation, or technically any polynomial equation that has a higher degree than 1. And let me show you. So if we were looking at x squared plus 4x plus 3 equal to 0, again, a quadratic equation, let's just say we take the equation part out of it. If we were just looking at this expression, hopefully we realize that it's factorable. We could find factors of 3 that make 4, right? 3 times 1 is 3, and 3 plus 1 is 4. And because this is a 1, we don't have to worry about any dividing, reducing with the bottoms up process. So this is going to factor into 1x plus 3 and 1x plus 1. Okay? Now again, factoring for the sake of factoring, not so helpful. But if we put the equation piece back in, put this equals 0 back in, then this is going to help us to solve. The factoring is going to help us to solve. Now hopefully you're looking at this and maybe you can see what our two solutions, remember we're looking for two solutions, maybe you can see what they're going to be. What we're using here is something called the zero product property, which to me is kind of common sense, but it basically says that anything times 0 is 0, right? If you multiply 3 times 0, you get 0. If you multiply 0 times negative 5, you get 0. No matter what you multiply by 0, you're going to end up with 0. So we have one factor here, we have a second factor here. If I could make at least one of them equal 0, then 0 times whatever happens here is going to create 0. Or same thing here, if I can make this factor equal 0, then whatever happens here won't matter because 0 times anything is going to make 0. So then, what is going to make each of these factors equal 0? Well, what makes x plus 3 equal 0? Would have to be a negative 3, right? The negative 3 would cancel the positive 3. So if I were to put negative 3 in here, negative 3 plus 3 makes a 0. If I put negative 3 in here, it makes negative 2, but 0 times anything, 0 times negative 2 in this case, makes 0. Okay, the other solution comes from the other factor. What makes x plus 1 equal 0? Well, this would have to be a negative 1. And if I plug the negative 1 in, again, if I plug the negative 1 in, we see a 0 for this factor, and over here I get 2, but it doesn't matter because 2 times 0 is going to make the 0 that we need in our equation. So what we want to do is use factoring to solve by including or incorporating this zero product property. Okay? So if we're going to solve by factoring, we want to make sure that our equation looks like this before we try to solve by factoring, which means we want all the terms to be in order and we need to have this equal 0. If it's not equal to 0, then this zero product property isn't going to work. So we want to get the equation in order and equal to 0. That's technically what we call standard form, right? Descending order equal to 0. And then we're going to factor completely, which sounds so simple, but that could incorporate lots of things. It could be factor by grouping, could be GCF, could be bottoms up, could be factor your difference of squares, whatever it is. We want to factor. And then we want to make each factor, or figure out what makes each factor equal 0, because those are going to be our solutions. Okay, the values of x that make each of the factors, each of the binomials that are in parentheses there, or whatever they are, equal 0, those are going to be our solutions. And the nice thing about solving, and these last two notice these aren't steps, just sort of bullet points here. The nice thing about solving is you can always check your answers by plugging them back in. So we could check our work by plugging in, and I wouldn't do that every time. You know, if it's a quiz where it means a lot, then definitely do it. But if you're just working through a bunch of problems, have some confidence that you're doing it right. And then the other thing is that we can have some direction looking at our equation up front. If we recognize that it's a quadratic or degree of 2, we're looking for 2 possible solutions. If it's degree of 3, 3 solutions, and so on. So the degree of our equation is going to dictate the number of possible solutions. Okay? So the first 2 problems I have here are already factored for us, already factored and equal to 0. So we don't have to worry about the first 2 steps. I just want to be able to show the process here. We want to know what makes each factor, in this case x plus 2 and x minus 5, what makes each of those pieces equal 0 will make the whole equation equal 0. So one of our solutions is going to be negative 2, and one of our solutions is going to be positive 5. And if you could do that work in your head, that's totally fine. I'm just trying to give you some thorough notes here, okay? Now, maybe it's not as easy to see the solutions, like over here, negative 2 cancels positive 2, positive 5 cancels negative 5. I think that's probably doable without work. Now, I'm not sure if you can see that as easily here, so maybe the work is helpful. What's going to make 2x minus 1 equal 0, and what's going to make 3x plus 7 equal 0? Well, here I would have to add the 1 over, so 2x would equal positive 1, and then I would have, to divide by 2. So 1 divided by 2 makes 1/2 one of our answers. Over here I'd have to subtract the 7 first, so 3x would be equal to a negative 7, and then divide both sides by 3. So negative 7 divided by 3 makes negative 7/3 our second solution. Okay, so maybe it's not as easy to see the answers there, but you've got the work. Although I would argue you really should be able to do that in your head too. Let me just show you once more. So if you had like 5x plus 2 and let's say 3x minus 8. I'm just making stuff up. So here, if I was in my head, right, making this equal to 0, what would I have to do to solve? Well, I would have to subtract the 2 and divide the 5, so negative 2/5 would be my answer. Which also makes sense if you think about the opposite of plus 2 is minus 2, and the opposite of times 5 is divide 5. Okay, and the same thing here, if you're in your head thinking what could make this equal 0, well, if I was solving for x on this one, I would have to add the 8 and then divide the 3, so positive 8/3 would be my next solution. Okay, so you can do that in your head if you feel comfortable with that. If not, feel free to do the work on paper. Alright, so now we have some that are not factored for us, so that's okay. So this is in order equal to 0. Good, which means we're ready to factor. And factoring in this case means all we're going to do is take out a GCF. These two terms both have in common an x. So if I factor out the GCF of x, that's going to leave me an x plus 7. And now that it's factored, I just got to make each of those factors equal 0 to make the whole equation equal 0. So x equals 0 is going to have to be one of my solutions. And what's going to make x plus 7 equal 0? Is negative 7, so negative 7 is going to be my additional solution. Okay, so there are my 2 solutions there. And again, I wouldn't do it every time, but if you really wanted to check your work, not so hard to do it. And you could do this in your head, but let me just show you. 0, obviously, 0 squared plus 7 times 0 is going to make 0. That's an easy one to check, right? What about the other? If you put in a negative 7 and you square it, plus 7 times another negative 7, do you get 0? Well, that's a positive 49, that's a negative 49, and in fact they do cancel. Right? So anytime you want, check your answer, and it should make a true statement when you plug it back in. Okay? Moving right along, this one, again, in order equal to 0, so it's got to be factored. And hopefully you're recognizing that those two terms are perfect squares. This is a difference of squares. What are we squaring to get 4x squared would be a 2 and an x. And what are we squaring to get 25 would be a 5, which means this is going to factor into a 2x plus 5 and a 2x minus 5 equal to 0. So here, what's going to make 2x plus 5 equal 0? Well, I would have to subtract the 5 from both sides, and then I would have to divide both sides by 2. So negative 5 over 2 would be a solution. And then here, the same thing is happening, it's just a different sign. So we're going to end up with the same answer, but a different sign. So positive 5 over 2. And it would be totally okay to leave those two separate answers, or we could also condense, because we have a positive and negative of the same number. We could say our solutions here are plus or minus 5 over 2. Okay? Here, again, this is in order and equal to 0, so it's ready to be factored. There's no GCF. This time we have a trinomial, so we're going to attempt this using bottoms up. So 4 times negative 6 would be negative 24. And we need some factors that are going to add to negative 5. So in this case, we can use a negative 8 and a positive 3. So those are the two numbers that multiply to negative 24 and add to negative 5. Now both those factors are going to be divided by 4. And then we're going to reduce. And now we're going to read these reduced fractions from the bottom up. So 1x minus 2 is a factor. And 4x plus 3 is a factor. And now that it's factored, we can get to our solutions. So what makes x minus 2 equal 0 would have to be a positive 2. And what makes 4x plus 3 equal 0? Well, here we'd have to subtract the 3 and divide the 4. So negative 3/4 is my second solution. So x equals 2 and x equals negative 3/4 are my two solutions. Now I just want to point out another really nice feature of the bottoms-up process. If you look at the answers or compare the answers, a positive 2, and the factor that we reduced over here in the side work, negative 2, or here an answer of negative 3/4, and over here this reduced fraction positive 3/4, it's not coincidence. Another nice feature of bottoms up is after you have divided and reduced your fractions, the opposites of these numbers in this little factor tree we've got going on over here will be your solutions. Okay, always. That will always work. Okay, the opposites of these numbers are your solutions. And I, knowing that and having a lot of experience doing this, use that as a shortcut. Let me show you again in this next one how I use that as a shortcut. Now if you want to try it, by all means give it a try. Feel free to pause. But so 2 times negative 3 is going to make a negative 6. And factors that make a positive 1 would be 3 and negative 2. Those are both going to be divided by 2. This reduces. And so now I can see my solutions are going to be the opposite of 3 over 2, which is negative 3 over 2, and the opposite of negative 1, which is positive 1. So that's how quickly we could get the two solutions to that equation. Now, if you don't want a shortcut, that's totally okay. We want to finish factoring this out. This is going to make 2x plus 3 a factor. And this is going to make 1x minus 1 a factor. And then here we can see, to make this factor equal 0, we would have to subtract 3 and divide 2. And then here we see we'd have to add the 1 over. Right? If x minus 1 has to equal 0, we add the 1 over, so x equals 1 is our second solution. Now again, it's the opposite of the numbers we have over here, so if you want to take that shortcut, knock yourself out. Otherwise, you can definitely do all the work. It didn't take us all that long, and those are our two solutions. Okay? Not so bad. Let's try a few more here. Now, number 6 and 7 not set up for us perfectly here. We do have terms in order on the left, but not on the right, and we don't have a 0, which we have to have. So the first step on number 6 is to actually get this in standard form. So I'm going to start by adding the x squared to both sides. If I add the x squared to both sides, that's going to cancel it from here. So 1x squared plus another x squared gives me 2x squareds. And then I can actually also add over the 23. Add the 23 to both sides, so that cancels. And negative 16. And this has got to be a typo. What did I do? plus 7. I think one of these terms was supposed to have an x. Maybe you're seeing the issue. Let me just show you why there's a mistake in this problem. I'm not sure what I meant to type here, but the only way we can factor two terms is if we have a difference of squares or a sum or difference of cubes, and this is none of those, so this can't be solved by factoring. This is just a poor problem. Sorry! I don't know what I meant to type there. Can't be solved by factoring. Doesn't mean it can't be solved. And when we get to a later module, we will actually solve equations like that. And some of you may know how to do that already, but it can't be solved by factoring. So this problem did not belong here. I clearly made some kind of a typo. So sorry about that. Okay, let's try this one then. So here, same concept where we want our terms in order and equal to 0. So I'm going to subtract this 9x squared over to get a 0. When I subtract it over, it's going to go in the middle so that this is descending order. So I'm going to have a 3x cubed minus 9x squared in the middle minus 30x and then equal to 0. And now I'm going to start my factoring. So hopefully you're recognizing that these terms all have something in common, and hopefully also you're seeing that this degree of 3 means we're going to be looking for 3 solutions. Okay, so let's take out the GCF first. All terms have in common a 3 and an x. So if that comes out, we're left with an x squared minus 3x minus 10 equal to 0. So we've got one factor, but the trinomial in the parentheses is still factorable. So in the parentheses, let's see, we're looking for factors of negative 10 that make negative 3, and negative 5 and 2 will do that. And if I divide by the 1 that's in front, that means we're going to have this GCF of 3x, and then in the parentheses, we end up with 1x minus 5 and 1x plus 2. Okay, and this is all still equal to 0. And now we've got 3 factors, which makes sense. We were looking for 3 solutions. So the values of x that make each of those 3 factors equal 0, we're going to give us those 3 solutions. So here, what makes 3x equal 0? Well, if I divided the 3 over, 0 divided by 3 is still 0. What makes x minus 5 equal 0 is going to be a positive 5. And what makes x plus 2 equal 0 is going to be a negative 2. So our solutions are x equals 0, x equals 5, x equals negative 2. Okay, and again, you could check those. And just to point something out that's kind of helpful to know, useful to know, if all of the terms in your equation contain an x, it should make sense that 0 is a solution. So all of the terms, this one has an x, this one has an x, this one has an x, means 0 has to be a solution. And that should make sense, right? If you plug 0 into all of those, what's going to happen to all of those terms? It's that same 0 product property that we talked about. Then all those things would 0 out. So if every term has an x, 0 must be a solution. And we actually saw that on a previous problem. I just want to point it out again here, right? Both of these terms had an x, and so 0 had to be a solution. So it's sort of a nice thing. Oops. A nice thing to sort of have in your toolbox if you can remember. I don't know, sometimes it's a lot to remember, but I'm going to make a little note here too. If every term has an x, 0 must be a solution. If every term has an x, 0 must be a solution. Whoops, that was supposed to be an n. Okay, and let's try here. If you're feeling confident, again, feel free to pause the video and give this one a shot. Otherwise, this one is in order and equal to 0, so we just need a factor. And because it has 4 terms, we're going to try to factor this by grouping. So GCF for our first group is going to be 9x squared, and that's going to leave us with an x plus 2. GCF for the second group is going to be a negative 1, which will leave us another x plus 2. And so now we have an x plus 2 in common. If we factor that out, then we're left with a 9x squared minus 1. And we're not quite done factoring. And there's a couple reasons that you should recognize why we're not done. 1, we're looking for 3 solutions, which means we should have 3 factors. 2 is this is a difference of squares, so we want to continue factoring that difference of squares. So this is the result of squaring a 3x, and then this is the result of squaring a 1. So we've got this x plus 2 as a factor, and now we're going to have a 3x plus 1 and a 3x minus 1 as our two remaining factors. So first solution, what is it that's going to cancel out that positive 2 in there? Is going to be a negative 2. And what about in the second one? Can you do that in your head? If you were solving for x here, you would have to do what first? You'd have to subtract the 1 and then divide the 3. And then in the last one, you would have to add the 1 and divide the 3. So we could say x equals negative 2 and x equals plus or minus 1/3. And those are our three solutions there. Okay? Number 8 looks kind of fun. Well, I guess my idea of fun might be a little different from yours, but this is an interesting problem because it looks like it's factored for us, which is what we want, except that it isn't equal to 0. Right? If I don't have a 0 over here, can I use the same property? Can I just say, well, what's going to make x plus 3 equal 9? Because anything times 9 makes 9? No, it's not going to work like that. The only way for this to work is if that 9 is a 0. So normally if we have something over here, we would just subtract it over, but where would I subtract from this mess? Well, the plus 3 and the minus 1, those things are trapped in the parentheses, so I can't subtract the 9 until those parentheses are gone. So this is a problem where I'm going to have to take this thing apart and then put it back together. So let's distribute this out. I get 2x squared minus x plus 6x and then minus 3 equal to 9. So that's 2x squared. I can combine these like terms. Negative 1 and positive 6 makes a positive 5x. And now I have a place to subtract the 9. That 9 can be subtracted from that 3. So that's going to leave me with, let me change back to a minus 12 here, and now it's equal to 0. Okay, so now we can factor this. Let's see, 2 times negative 12 makes a negative 24. I can use a positive 8 and negative 3 to multiply to negative 24 and also add to 5. I'm going to divide these both by 2. And now I would shortcut to my solutions. I know that x is going to be equal to a negative 4 and x is going to be equal to a positive 3 over 2. But if you don't want to shortcut, totally fine. Okay, let's finish this off here. So this is going to factor into 1x plus 4. And then this is going to give us a 2x minus 3. And so what's going to make x plus 4 equal 0? Is going to be a negative 4, like I said earlier. And what's going to make a 2x minus 3 equal 0? Well, if you add the 3 and divide the 2, then 3/2 is your other solution. So again, x equals negative 4, and x equals 3 over 2. All right, moving right along. Let's see, number 9 is a similar process, and if you know another way to solve this, we will talk about other ways to solve quadratics in a later module. But if we're trying to solve this by factoring, we have to undo this just like we did on the last one. So 3x plus 1 squared means 3x plus 1 is being multiplied by itself, and it's equal to 1. And in the place of that 1 there, we need a 0, and I can't subtract it until I actually multiply this out. So I'm going to have a 9x squared, a 3x, another 3x, and then a plus 1 equal to 1. So that's 9x squared, 6x's total, and now I can subtract the 1 over. If I subtract the 1, both of those cancel, and so I'm left with just those two terms equal to 0. And now we can factor. And this time we can factor just by removing a GCF. So both of these terms have a 3 and an x in common, which would leave us a 3x plus 2. And now I can get my two solutions. So if 3x has to equal 0, then 0 has to be an answer. Again, each of these terms has an x, 0 had to be a solution. And then over here, if 3x plus 2 has to make 0, we would subtract the 2 and divide the 3, so negative 2/3 is our second solution. So 0 and negative 2/3. Okay? I've got one last problem here. If you want to try it, you're feeling pretty good about this, give it a shot. If not, here we go. Just like the last two, take it apart. It's going to give us an x squared and a 4x. And then let's subtract over the 77 to get it equal to 0. So now we're in order equal to 0. And we can factor factors of negative 77 that make positive 4. We're going to be 11 and 7 if the 7 is negative. dividing by 1, not going to change those. So this is going to factor into 1x plus 11 and 1x minus 7, which means our solutions are going to be negative 11 and positive 7. And really easy again to check, and you don't need to go away, calculator. Really easy to check, and you could do this in your head, but just so I can show you on paper, if you put negative 11 in, negative 11 times negative 11 plus 4 should equal 77. Well, does it? Well, this is negative 11 times negative 7, and yep, that product is positive 77. Or if you plug the 7 in, 7 times 7 plus 4, does that give you 77? Yeah, that's 7 times 11, which is still 77. So you can check them in your head, you can check them on paper, you can also just check in your calculator if you don't feel like doing that work. And sometimes you won't, because sometimes they're ugly. So we're saying x is 7. If we were to type in, or negative 11, let's try that one, and then type it in, negative 11 plus 4, and then when you see the equal sign, right, that's where you stop typing and you see it equals 77, which is exactly what we want it to happen. So check your work if you aren't feeling good about what you did, or if you work through a practice problem and it marks it wrong for you, then plug your answers in and make sure you've got the right ones going there. If it's multiple choice, it's like fail proof, right? Okay, so that's concluding our review of factoring and why we're learning how to factor. One of the purposes of factoring, which is to solve polynomial equations with a degree larger than 1. All right, so you've got some practice to work on. No quiz for this module, just good practice for you. And this concept's definitely going to be coming around in the next module. But as always, if you are struggling or you need some extra help, or just need some guidance as you're working through some practice, then reach out. I'm here to help. All right, guys.